So we're looking at more of differentiating by substitution today, or at least for the first half. So let's see how we can go about this problem. And I'm going to go in a different order kind of, only to kind of build your knowledge. One is going to stay as it is, but I'm going to jump to the bottom after. And I know when we get to trig, our brain goes, I don't remember, so let's do that last. And if you have your flashcards that we made of the integration, trig integration, take it out. Just for the purpose of at the end. Here it is. And I'll put it up here if y'all need. All right, on example number 1, we are solving for y. And after we solve for y, we're going to plug in y equals 0, x equals 0 to get that particular solution. So let's start by the following. What must I multiply the whole thing by to get rid of that fraction? Dx. So I have dy is equal to 24x of 3x, not 3, yeah, it is 3x squared, minus 1, all cubed, and dx, of course, at the end. And how can I get rid of the d and make y by itself? What must happen on both sides? We need to integrate. And that's going to cancel everything out on the left side and make y by itself. So we have y is equal to. Now, going back to last week, when there is a whole number or a fraction, we are allowed to bring that to the front. So I'm going to bring that to the front. You can keep it until the very end, but I think it'll be neater if we brought it to the front right now. So we have x of 3x squared minus 1, all cubed dx. So at this point, we kind of move things around. So let's see what we would need to do to use substitution. So last week I told you guys typically it's inside the parentheses, right? And if there's 2 parentheses, you take the more complex one. So we know this one is our u. So off to the side, let's write out u is equal to 3x squared minus 1. What is the derivative of u? Of u? 1 du. And I heard the derivative of 3x squared is 6x. Is that right? Dx. And then we have to ask ourselves the following. I have dx, so we're happy. We also have an x, so we're good with that one. I need to get rid of the 6 by doing what on both sides? Divided by 6. So now that it's identical, I can go ahead and rewrite it. So when I rewrite, we're going to get the following. Y is equal to 24. What can I do with 1 over 6 when I do end up plugging it in? We're going to bring it to the front, so might as well right now. You can leave it inside first if you want. So then, the one that we circled was our u substitution. So u cubed. And all of the x dx now became du. So now we can integrate. So when I integrate, I am going to leave the outside as it is for now. You can compute as you go, but at some point, it becomes cleaner if you compute at the very end. So on u cubed, that is 1 over 4, u to the power of 4. Plus what? Plus c. du goes away when we integrate. And then I want you to notice something right here. If I simplify the 24, 1 over 6, and 1/4, what does that become? 1. So let's rewrite this. Y is equal to, and that part is 1. In place of u, let's plug it in. 3x all squared minus 1 to the power of 4 plus c. The only new thing today we're doing on top of 4.5a from last week is plug in the 0 into our y and then the x. So let's see what we would get. Y is 0, and I have 3 times 0 all squared minus 1 to the 4th plus c. And all of this right here that I have underlined is going to be 0. So that really, in the end, is going to give us negative 1 all to the power of 4. If you have even number of negative 1s, what kind of 1 do I get? Positive 1. So that tells me my c must be negative 1. So if I go ahead and write out the equation by plugging in the c, we get the following. 3x squared minus 1 all to the 4th minus 1. And that is our final answer. So you solve for y, plug it in for x and y, find the c value, plug it back in. So most of these should sound like a review, okay? Okay, let's go to the bottom, my number 2. So moving on up. So let's start by rewriting y prime as what? dy over dx. And let's rewrite the radical as a power form. 1/2 power is equal to x. So again, the first thing we are going to do is to get rid of the fraction. What are we doing on both sides? Multiply the whole thing by dx. So I now have dy of x squared plus 1 to the 1/2 is equal to x dx. We're still solving for y. So what should I get rid of before I integrate? What's right next to it? That's being multiplied, right? So I'm going to divide the whole thing by that component. So we're doing algebra 1 if you kind of think of it in that sense. So we know that is going to knock out and reduce to 1. So I now have dy is equal to that component. Now when I rewrite this, I do not want to write this as a fraction. Let's write it with a negative power so I can bring it up to the top. So now what can I do on both sides to make y by itself? We can integrate. So when I integrate, I now have y by itself. Let's do our u substitution. What is going to be our u? X squared plus 1. Let's put it all over to the side. U is equal to x squared plus 1. So we know du is 2x dx. And let's go ahead and compare. I have an x, I have a dx, which I have. What is missing? The 2. So divided by 2. So now let's go ahead and put them back in. Let's bring the 1/2 in front again. Integrate. And our u substitution to negative 1/2 du. And the 1/2 I'm just going to keep out here again. Let's integrate this guy. When I do, I get 1 more of negative 1/2 is what? Positive 1/2. U to the 1/2 plus c. And let's worry about this right here. Sometimes when we're looking at the simple math or the simplifying is where we kind of mess up. Y'all ready? 1/2 of 1 is how many? Not half of 1. 1 divided by half is how many? 2. And if I take 2 and half of that is how many? 1. So all that is basically 1. So I have, if I were to plug in the u, we get, y is equal to x squared plus 1 to the 1/2 plus c. And at this point, it didn't tell us what x and y is equal to, so we can't go on any further. And that's it. So be really careful when you're doing the simplifying fractions or doing the simple math per se. So now let's do some reminder on our trig function. So let's go to our number 3, which is the original number 2. The first thing we are going to do is rewrite something. What are we going to replace with y prime? dy over dx. So we have dy over dx of our sine squared of x is equal to cosine of x. And y'all notice it gave us what the domain and range is here on this one, x and y I mean. So at some point we have to find the c value. And that might be the part we might need some reminder. So what should happen on both sides first? Multiply the by dx. So I have dy of sine squared of x is equal to cosine of x dx. That's a wonky s. And then we're going to divide it by sine squared. Again, this part is the algebra piece. And it's going to reduce. So we now have dy is equal to. Now I'm going to write this in a certain form. So watch carefully. I'm going to take sine squared and divide into 2 pieces. So the first one, I'm going to put it with cosine. Second one, the cosine is gone, so I need 1 over sine of x. So then that way I could write those fractions as a single trig function. So when I do, we get the following. Ooh. dy is equal to, if sine over cosine is tangent, then cosine over sine must be what single value? Cotangent of x. And 1 over sine is a reciprocal of some value. We know the reciprocal of sine is what? Not secant, but cosecant. And if you're like, well, it's been a while, just practice the ones that I give you on the homework as a reminder, because it's going to eventually, hopefully, come back to you. Let's go ahead and integrate. When I integrate, I get y is equal to the following. And here's a reminder. These, hopefully, you're memorizing every day. So when I integrate cosecant, cotangent, that gives me negative cosecant. And we have plus c. So then we know my x is pi over 6 and my y is 0. Let's plug it in. 0 is equal to negative cosecant of pi over 6, and then we got plus c. Let's see if y'all remember where we drew pi over 6 back in pre-cal. Which quadrant was pi over 6? The first quadrant, so that's pi over 6. And if you remember the ratio, opposite of pi over 6 was 1. What was the adjacent? Radical what? Oh, 3. The 2 went into our hypotenuse. So then we know our cosecant is reciprocal of sine, meaning we have hypotenuse over the opposite. From the reference angle, that's my opposite, and that's my hypotenuse. So let's write in here, 0 is equal to negative. Just the cosecant of pi over 6 is 2 over 1, so 2 plus c. So that lets me know c has to be how many? 2. So our final answer is y is equal to negative cosecant of x plus 2.